Hi guys, so in this video we going through what odd and even functions are, um the DC components, and how to know if the signal has a DC component in it or not, right? So from what we've been doing before, the DC component is always the constant or the number. All right, so let's see if we have one. So in this case here, this here is a DC component, right? But this is when you're working with sines and cos when they already give you it in trig form, right? The other form that you need to know how to do is when they give you a piecewise function like this, where you have to plot the graph and get the Fourier series from the graph itself, right? So there's a different type of Fourier series, right? So the most important thing you need to know is, as again, what odd and even functions are after you sketch it to know if it has a DC component in it, right? So firstly, an even function is any function that obeys this law here. The law states that f of x is equal to f of minus x, right? Example of this is our cos x function. So if we go across the Desmos and we do cos x, right, we notice that in this here, for zooming, you'll notice that f of x, so let's say f of 1, right, which is this point here, right, sorry, 1 here, is this value here. Right? And if you reflect it on the x-axis for -1, which is, so this is f of x, and this is f of minus x, you will notice that they are at the same value, right? So therefore, this function here, which obviously is cos x, will be an even if you had pick a next value, say f of -3, the flip of that will be f for 3, which is on this side here, right? So I'll just write it in. This here is f for 3. Right, so you'll notice that they both are the same value. Yeah, so this function here is even. And we already know that cos is an even function. Right? So that's important to know, right? So let's go across here. So even function, example cos, it will be is f of x equal to f of minus x. The other function that you need to know is an odd function, right? And an odd function will be is f of x is equal to minus f of minus x. So just sine. So let's see how sine x looks. So if you look at sine and we analyze it, so let's pick f of x. So let's do 1. So we know f of 1, which is like f of x. And if we invert it, so get f of minus x, which is here, you'll notice that is the negative of this value here. Yeah? So this is f of minus x, but it has a minus because it's inverted. All right, same thing for -2 and 2. You'll notice that the value is inverted. All right, so it obeys that f of 2 is equal to minus f of minus 2. So therefore, this function will be an odd function, right? Hence it's sine, right? And ironically, any function that does not fall under any of these two will be both odd and even. So if it's not even and it's not odd, it's not neither. It's odd and even. So that is something for you to remember, right? You'll do more practice on this just in a bit. And the last concept is the DC component. So it has one law. If the area under the graph is equal to the area above the graph over a period, right? There will not be a DC component in the Fourier series of the signal, right? So if the area, so if you look at this graph here, so over a period, right? So let's say a period is in this case 3. Let's zoom out and see what will be a better period. Since it's sine, we use what we are accustomed with, which is right here. So this will be a period of sine and same. So we start it here. So we'll use this period here. Yeah, let's pick a period. It doesn't matter which period it is because it's Fourier series we're doing. periodic signal, so always repeat after a period of time, which we call it T. T stands for a period, right? So it's something to remember. So if you look at the area above here is equal to the area under. Yeah, so what happens is when you add these two areas together, algebraically, this is plus and this is minus. So they'll cancel each other and you'll end up with 0 as the DC component. Yeah, so clearly the area above is equal to the area underneath. So it will cancel to give you 0. So let's see when it will have a DC component. So let's say we added a shifted, so 2 plus, right? So you can clearly see in this case, the entire graph is over the x-axis, right? So you have nothing on the negative side. So therefore, this entire thing is positive. So positive minus 0 negative will be only positive. So therefore, this signal here will have a DC component in it. Yeah, because as you notice, I have nothing underneath. So that's end up with a positive area when integrated, subtract no negative. So obviously you'll have a DC component in it, right? Even if I were to do, let's say, minus 2, right? So we clearly see the area above positive and the area will be negative here. So the area above is not equal to the area underneath the graph on the x-axis. So therefore, this will have a DC component compared to this, where the area above was equal to the area underneath, right? So this will have no DC component. So let's try cos. Right, so cos, on the other hand, let's pick up period, right? So let's see where we could use the period. So we'll start here, and we'll custom and go to here. Right, so let's see the area above will be equal to the area underneath. So this will have no DC components, right? And then if I was to shift it, clearly see that the area above is not equal to the area underneath. So this will have a DC component, right? Let's try a weird one. Say plus sine 2x. All right, so in this graph here, it is a periodic function, right? So I think the period going from here to here, or you could say going from here to here, right? You can clearly see that the area above is not equal to the area underneath. Yeah. And if we use our odd and even analysis, we clearly see that it doesn't obey the f of x is equal to f of minus x. Why? Okay, if I pick, let's say I pick this point here and I mirror it, it's clearly not going to the same value. So it is not even, and also it's not odd. Why? Because this here, if it was odd, it will end up being this here. So it's not odd, not even. So this is a odd and even. So it's both odd and even. Right? So when it's neither, you have to do odd and even. Right? So it doesn't obey. Once it doesn't obey neither the even or the odd, you have to operate like it's both. Yeah, and you'll see that more when you show you the actual how to do the actual question. Right? But for now, just I'd appreciate that. Right?